Today I'm going to talk to you about basic genetics, which is often described with the Punnett Square, and you'll see a few other things going on with that as well. First off, I want to apologize for this presentation. It is a PowerPoint that has been translated into Google Slides, so it doesn't really work very well. I had to turn in my computer before this pandemic lockdown, so I don't have my original file. Anyway, genetics first started off with Gregor Mendel. He was a Catholic priest who did a lot of studies on genetics, particularly on pea plants, which was nice because plants are very simple in terms of their genetics and their chromosomes. They tend to have lots of chromosomes, lots of little chromosomes with just a few genes on them, so you can actually follow the genes a lot easier than you can do in humans. So I'm not going to go through his whole process of who he is, but he did do studies on pea plants and figured out the laws of heredity. Two terms you should have learned last week are dominant and recessive. So dominant is the trait that shows up in the offspring. If you have one of these, you are going to see it. A recessive trait is masked by the dominant trait. You may not see it if there's a dominant trait there. You need to have generally two copies of those genes to see that trait. The 7 characteristics he studied are as follows. I'm not going to go through a lot of them, just point out with flower color, purple was dominant, white was recessive, seed shape, round was dominant, wrinkled was recessive. Seed color, yellow peas is actually dominant to green peas. That's a good indication. Just because something is dominant doesn't mean it's the most common. Many of the recessive traits are more commonly seen than the dominant traits. All right, so what he did was he had what he called the F1 generation. These were his original, these were crossed from the original pea plant. So he started with true breeding stocks. These would have been the parent generation that would have created this F1 generation. So he had, these pea plants that were true breeding always bred those traits. So green peas always had green pea plants, yellow peas always had yellow pea plants. They were true breeding for those traits. He would then cross these two traits. So he would take a yellow pea and a green pea plant and cross them so that they would interbreed. And the offspring of those peas he called hybrids, because basically they had one copy of the yellow pea gene and one copy of the green gene in there. So this is often referred to as the F1 cross. And F basically it's a Latin word. You gotta remember he's a priest, so he was using Latin words. So filius means son, so it's called F1 for that reason. All right, so if we look at the traits, we've got the pure green peas up here and the pure yellow peas here. When we talk about these traits, when we have a dominant trait, we're going to use the letter Y because it's the dominant trait. Doesn't matter if it's green or not, we're still going to refer to the color as, in genotype terms, as Y. And that's just the way things are done so that you know that this is the dominant trait. So anyway, what he did when he first did this trait was he took the parent generation, crossed them, so he had a green pea crossed with a yellow pea, and he found in the F1 generation that they were all yellow, 100% yellow. They would have one green gene and one yellow gene in each one of these peas, but because yellow is dominant, that's the color you see. And then when he crossed it again, he found that for every 3 yellow peas he had one green pea. Or you could have said 75% were yellow and 25% were green. So that was what he saw in the F2 generation, which was the F1 generation. All right, so This is basically what he saw. Basically, he's looking at meiosis. So he did not know anything about meiosis. People in this day and age really didn't know where babies came from. They knew that mom and dads were needed, but that was about it. So he didn't know anything about meiosis. He really didn't know anything about cells, but he was still able to figure out what was going on. He knew that the he knew what the female part of the plant looked like, what the male part of the plant looked like, and so he was figuring there had to be one moving to the other. So basically, to get this green pea, you had to get one little y from dad, one little y from mom, because we get 2 genes for basically each trait we have. And in this case, since they're with the recessive traits, we're going to end up with a green pea. So that's what we're going to look at, is how did these things pass down? Where did they come from? So he basically said that the dominant trait for yellow, he named big Y. And if you had at least one big Y, you would have a yellow pea. The green pea was labeled as little y. And I know that's going to be probably cut off because the way this presentation works, but that's there, little y. So his parent generation was little y, and the other one was big Y. You remember the pedigrees from last week. So one little y came from the green pea, one big Y came from the yellow pea. So everybody was big Y, little y. In other words, they were all yellow. As long as you have one big Y, you're going to be yellow. You then let them cross, and there's lots of things that can happen here. So in this case, if you get a big Y from the one parent and you get a big Y from the other parent, you're going to be big Y. In this case, you get a big Y from this parent, a little y from this parent, and you got big Y, little y, or otherwise known as yellow. And in this case, it's just the opposite. We got the little y from that parent and the big Y from that parent. So that's another possibility, but of course you're yellow. And the final possibility is you get this little y from that parent, a little y from that parent. Of course, that one's going to be green. And we got our 3-to-1 ratio to make a green pea. All right, often we'll do this with a Punnett square. So let's just talk about Punnett squares real quick. I will show another video be available for you for Punnett squares. This is just a quick thing about Punnett squares. So first thing, you have to have the symbols for the parents. So we know that we're going to cross basically a yellow pea with a green pea. So we know that the parent, one parent is big Y. The other parent's little y. So then we're going to put those by each of the squares. And I know most of you have done a Punnett square before, so this shouldn't be anything new to you. So one big Y goes over here, one big Y goes over here. And for here, one little y goes here, one little y goes here. And then we start filling in the square. So remember, the parents each have 2 letters, 2 y's. These have 2 y's, so the children need to have 2 y's. So that's why we're splitting them apart. So we got to look at the possible genotypes. So the genotypes are the letters. So the best way to go is just to go down, big Y. And if it's a big letter, I always write it to the left. And if it's a little letter, I would write it to the right. And we go down on this side, big Y. Then we got to come across. Little y. So our results for genotypes is we get 100% big Y, little y. And our phenotype is, what do we see? 100% yellow. So we got 4 out of 4 big Y, little y. 4 out of 4 yellow peas, 100% each way. All right, so now let's look at the hybrid cross. In this case, the parent's going to be big Y, little y. And this parent's big Y, little y. So we put a big Y or a Y over each square. Big Y here, little y here. Big Y here, little y here. And then we fill it in. So we end up with big Y, little y, big Y, little y, little y, little y. So our genotype is just what is in the squares. There's really shouldn't be any hard thing with a Punnett square to figure out genotype. It's just the letters in the squares. All right, so this one's going to be yellow because it's got a big Y. This one's going to be yellow because it's going to be has a big Y. This one is yellow because it has a big Y. So we're going to have 3 yellow peas. One of them is big Y, the other 2 are big Y, little y, but there's all yellow, so they're going to be yellow. And then this little guy here, little y, because it's got 2 recessive traits, it's going to be green. So we're going to have 3 yellows, 1 green. So our phenotype is going to have a 3-to-1 ratio. If we're going to look at genotypes, it's 1-to-1 ratio. On these questions, you can either answer them in terms of percentages or just look at the numbers. Our ratio is 3-to-1. 1, 2, 3, 3, and 1, 3-to-1. All right, and then he came up with the law of segregation, law of independent assortment, which basically is just an explanation of meiosis in both cases. And the law of dominance, as long as there's a dominant gene, it will dominate the recessive trait. All right, we're going to end this particular set of notes here. I would make sure you have a few copies of the notes, understand what dominance means, understand what recessive means. If you got one dominant gene, you're going to see the dominant trait. That's how these work. All right, and make sure you know how to do a Punnett square. Let's see, we can end this. So let me do that and put on this real quick just so we kind of look at this again. So if we're looking at A's in this case, we're going to make the dad big A, mom little a, little a. Remember, one little a is going to go here, one little a is going to go here, one big A is going to go there, one big A is going to go there. We can mate them like this, and you can see how the Punnett square fits in. And if we want to look at percentages, we will see if we're looking for just a recessive one showing up, there's a 0% chance it's going to happen. Let's reset that and do it again with the hybrid ones. And what's the chance of having 2 recessive traits here? So we mate these, they spread apart, and we fill in the squares. This time, we have a 25% chance of having 2 recessive traits. We can also do this another way. Show you one more hybrid here. Well, put the dihybrid there, or the hybrid there, and we'll put a recessive one here, and we'll mate those. And if we look at the percentages, we'll see it's 50% chance of having that recessive trait. So keep in mind with these Punnett squares, your only choice is 100%, 75%, 50%, 25%, or 0%. For some reason, some students want to give me 60% or 30%. Well, there's no way that can happen. So keep that in mind. We're talking about 4 squares, and so your percentages should work like that. I will put up this website link so you can kind of play around with it to get a feel for how Punnett squares are done. So you ought to be able to figure out the Edge Elastic quiz real quick. So make sure you remember it's open notes. Use your notes. Have them open. I will have a copy of the notes I just showed you. I'll put also a copy of the honors notes so you can look at those as well as you're doing the practice. So, or the monohybrid practice. So make sure you use your notes. Make sure you get a good score. If you want to retake the test because you don't think you did very good, just let me know and I'll reset the test for you. All right, that ends these notes.